Hey guys, so if we want to solve a fractional equation or an equation where we have variables in the denominator like this, it can be a little messy. The best way to go about doing it is the strategy that I teach, which is multiplying by the least common denominator or the least common multiple of your three denominators or however many denominators there are. So in this case, let's take a look at our denominators. We have 8x, 6, and 3x. And ultimately what this strategy does, if we do it correctly, we're basically getting rid of all the denominators and making it look more like a normal equation that we're used to seeing, rather than having x in the denominator. So if we think about those three numbers, or terms I should say, 3x, 8x, and 6, the least common denominator is going to contain an x. Okay, because at least one of them does, and as a matter of fact, two of the terms have an x in them, so the least common denominator is also going to contain an x. Now, numerically, we have 3, 6, and 8, so you're trying to find the smallest number. This will work if you use any common multiple. The least common multiple is just going to make it easier to cancel and things like that. 3, 6, and 8 all go into 24. Okay, so our least common denominator is going to be 24x. Now, what we're going to do with that, we're going to multiply, I'm just going to erase the red circles. We're going to multiply each and every term by that 24x. Okay, and we're allowed to do this because, just like if you're doing a system, as long as you multiply the entire equation throughout, so each and every term by the same term, or whatever it is, constant, the equation is still going to be equivalent. So I'm multiplying let's start with the right-hand side, 24x times this. 3x and 24x are going to cancel, and 24 divided by 3 is 8. So this is going to leave as a remainder here times 8. The x's cancel out. X divided by x is just 1. That's what I mean by canceling. So we'll do the math now. 2 times 8, this is just going to work out to 16. So instead of having 2 over 3x, I now have 16. When I was able to cancel. On the right, and let's not forget that we're multiplying both terms here by 24x. If you want, you can write it in here as well. Okay, the first one, 24 divided by 8 is going to be 3. So I'm going to have a 3 left over. And the x's are, once again, we have x in the numerator, x in the denominator. Those are going to cancel. So I have 3 times 3 left over. Okay, which is going to give us a 9. With the middle term over here, 1/6, when I multiply by 24 over x, the 24 and the 6 are going to divide out to 4, or cancel out with the 4 up top. There's nothing to cancel out the x here, so there's a 4x left over up top, times 1. 4x times 1, which is just 4x. So you can see what happened. I went from an equation with 3 messy looking fractions there to something that's a little bit easier to work with now. Okay, this is basically just a two-step equation now. Things you want to be careful of, canceling. When I'm saying things like canceling, we're really dividing, right? 24 divided by 6 is 4. There's nothing to divide the x with. That's why the middle term was the only one that had an x left. The first term and the last term all the way on the right had an x in the denominator, so that canceled out with our LCD. Okay, and now solving this, I would subtract 9 from both sides. This one's not going to work out perfectly, we could see. And then divide out the 4, and you're going to get x equals 7 over 4. Or if you want to write it properly, 1 3/4, so 1.75. Okay, and as always, you could check this by plugging in and verifying that it satisfies the equation. So, a little quick wrap up. Anytime you have variables in the denominator, multiply by an LCD, or least common multiple, to get your denominators to cancel out, and that makes it a little bit easier to work with. Okay, hopefully this was helpful.